So this exists. Apparently in 1867, Edouard Lill, he's Austrian, but he published in French, so I don't know how to pronounce his name. Published an account of how to solve any degree polynomial using a construction in 2 dimensions. You just draw lines, and all of the lines are perpendicular to each other. That's all you gotta do. The lengths of the lines are, of your original image, are the coefficients, including the sign, of, so that the sign will dictate direction. And generally we go counterclockwise in the direction of like radians, right? So a negative will take you in the other direction. Yeah, Lill's method can solve any degree polynomial, and it can handle the complex solutions. So you can find the roots to any degree polynomial with this general solution. This appears to contradict the claim that Galois theory proves that we can't solve quintics or higher in a general way. I'm not sure if there's something here that I'm missing, or if everyone is just really committed to the idea that Galois theory legitimately proves that you can't solve quintics or higher. But everywhere I see anyone giving examples of this, for one, they're hard to find. Two, anyone giving examples of this only goes up to degree 4. But if you read this, it doesn't say anything about that. This works for any degree. Degree 4 is not your limit. He gives examples. This is a degree 3, right? So there's 4 lines, 1, 2, 3, 4, right? Because you get 4 coefficients. The last one being on x to the 0, which ends up being your constant, right? So x cubed minus 6x squared plus 11x minus 6. You got 4 numbers there. So this is a general solution to any polynomial provided in terms of the coefficients That's exactly the thing that Galois theory allegedly proves is impossible to do for quintics and higher. What? And this was provided about 25 years after Galois theory. A little bit longer than that, after Galois died in a duel. Because, of course he did. Yeah. So I guess it was in like 1843 or something that somebody who really bought into Galois presented Galois' work to other mathematicians, and it was published in 46, I think. Something like that. Yeah, I think it was 46. So 177 years ago. And this was presented by Lill about 25 years later, give or take, depending on which date you're considering. About 150. This would be 156 years ago, and a year after this, he presented this, which shows how to find complex solutions. And again, he doesn't indicate that this only works up to degree 4. Unless I'm misunderstanding what he's saying here. Which is entirely possible. My French is not perfect. So here we have a 4th degree. That he's using as an example in here. But this entire thing, all he's doing is he's using that as an example. Right? So up here, in a previous article, he showed a way to demonstrate this graphically. Yada yada, after having that representation. Yeah, this is an example. He's using a 4th degree as an example. But here he used a cubic as an example. But here, like, first off, he's, this is generalized, right? This m can be anything. M can be any integer, right? That's what it says right there. This can be an equation of degree m. M can be fucking anything. And, the letters are numerical coefficients, right? That's what those are. And he starts going into an example with cubics. And here's an example of a cubic. So here, he's using an example that is a quadratic, but that doesn't mean that it's limited to that. The entire premise here is that it is not, in fact, limited to that. So I find that interesting. Why have we? So is he wrong? Does it not generalize this way? Does it only go up to quadratics? Because he's claiming that it goes to anything. And I've only seen examples up to quartics. So either Lill is wrong, or everyone else is. But even if everyone else is, when you look at the way they describe Lill's method, they describe it as being able to handle any degree polynomial. Which means Lill's method is a generalized solution for quintics, degree 6, degree 3 billion, degree anything, in terms of the coefficients, which according to Galois theory should be impossible. So what the hell is going on here? This is really interesting. So regardless of what the answer there is regarding quintics and higher, this is a really interesting question, because what the hell is going on here? There is definitely a paradox at play here. Why? Why are we claiming both of these things simultaneously that contradict each other?